Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on additional types of functions. In the last lesson, we reviewed the mathematical concept of relations. We also learned about inverse relations and how to sketch them. Today, we will learn about power functions. We will also learn about modulus, signum functions, and greatest integer functions. Let us get started right away. Do you remember what a function is, students? It is a relation in which no two distinct ordered pairs have the same first element. If f is a function with domain A and range a subset of B, its notation looks like this. If function A to B is given by a rule that maps x from A to y in B, then we write that y equals f of x. Let us try an activity, students. Here are three sets of relations. Which are functions? Which are not? With a partner, try to identify the functions on this list and explain your answer.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Were you able to tell which relations are functions? Relation A cannot be a function, as two of its ordered pairs have the same first element. Relation B is a function. None of its ordered pairs have the same first element. Relation C looks as if it is not a function because all of its ordered pairs share their second element. But C actually is a function. Functions can share their second element just as long as they do not share their first element. If those were your answers, good work. Now let us learn about power functions. A power function is a function which can be written in the form f of x equals ax to the power of r. R is a rational number, and a in the set of real numbers is a fixed number. Power functions are not to be confused with exponential functions. An exponential function consists of a fixed base raised to a variable exponent. A power function consists of a variable base raised to a fixed exponent. Let us try an activity with a simple power function. F of x equals 2x cubed. First, determine the function's range and domain. Then, using a table of values, sketch the graph of f. Finally, determine the parity of f and investigate its symmetry. Do your best, students, and I will see you in a few minutes.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello again, students. Let us follow these steps together. The domain of f and the range of f are both the set of all real numbers. Here is the table of values for the function. The table allows you to sketch the graph of the function, which should look like this. Now we must determine the parity of the function. This means we must see whether the function is even or odd. Since f of negative x equals 2 times negative x cubed, which in turn is equal to negative 2x cubed, the function is odd. Because the function is odd, f is symmetrical to the origin. This is verified in your graph, is it not, students? Good. Now, we must learn about a few other types of functions. There is an absolute value function, which is also called a modulus function. For any real number a, the modulus of a is defined this way. The absolute value of a is equal to a if a is greater than or equal to 0 and negative a if a is less than 0. In other words, the absolute values for x and negative x are equal for any x in the set of real numbers. A Signum function is defined by this formula. Y equals f of x equals Signum x. This equals 1 if x is greater than 0, 0 if x equals 0, and negative 1 if x is less than 0. The domain Signum x is the set of real numbers. The range of Signum x, by contrast, is negative 1, 0, 1. A greatest integer function is also called a floor function because it denotes the largest integer that is less than or equal to x. This integer is known as the floor of x. Let us review the uses of these functions, students. With a partner, do your best to answer all 3 questions.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Have you finished, students? Let us review the answers together. We will begin with f of 0.5. The floor function of 0.5 equals 0. The signum function of 0.5 equals 1. 0 plus 1 equals 1. The floor function of negative 2.3 equals negative 3. The signum function of negative 2.3 equals negative 1. Negative 1 plus negative 3 is negative 4. Now for the last function. The floor function of the square root of 3 equals 1, and the signum function of the square root of 3 equals 1. 1 plus 1 equals 2. I am sure that you had no trouble finding the correct answers to these questions. Today we have learned about power functions, which must not be confused with exponential functions. A power function consists of a variable base raised to a fixed exponent. We also learned about modulus functions, signum functions, and greatest integer or floor functions. Be sure to practice using all of these functions so you may master them. That is all for today. Until next lesson, thank you, teacher. Thank you, students.